Hello everyone. This is Dr. Prashant Sungar, Assistant Professor, Department of Structural Engineering, Sanjeevani College of Engineering, Savitribai Phule University, Maharashtra. So today I am going to talk about what is column and what are the different types of column and how the load is going to be taken care by the column. Column is a compression member. It is one of the structural elements that are pushed together to carry the load. When the load is applied on the column, it tries to pushes that member. So that's why it is called as an compression member. Columns are subjected only to an axial compressive force. The loads are applied on the longitudinal axis through the center of the member cross section. You can see here the loads applied on the longitudinal axis through the center of the member cross section, and the load over the cross sectional area gives the stress on the compression member. For a column, the principal stress comes mainly from axial force. So axial force is a predominant force in the column. So in addition to that, we will be getting a moment as well. First, let us see what is an axial load in the column. It is the force with which its resultant passing through the center of the particular section and being perpendicular to the plane of the section. As you can see, the load is acting at the center of the particular section. There are two types of load. One is concentric load and another is eccentric load. If the axial force is acting through the center of the member, then it is called as a concentric load. If the axial force is not acting through the center of the member, then it is called as eccentric load. That means the load will act some distance from the centroid of the member. So in that case, it becomes eccentric. So due to that eccentricity, the movement will develop in a column. If the axial force is not acting through the center of the member, you can see here this load acting some distance away from the center of the member. So that load is called as eccentric load. So due to this eccentricity, we will be getting movement in the column. So next one is axial load with a uniaxial bending. So here the axial force P is not acting on the center of the member. It is said to be eccentric. So that eccentricity, we can call it as Ex. Due to that eccentricity, a movement will develop in any one axis of the column. So if it is acting away from the member in the X direction, so the movement will be in a X direction. If it is acting away from the Y direction, then we will be getting movement in Y. So the bending takes place in any one axis of the column in uniaxial bending. Next one is axial load with a biaxial bending. That is what we are going to see now. So the biaxial bending means the load will act away from both the axes. That means X axis as well as the Y axis. You can see here this load is acting away from the X axis as well as Y axis. The axial force P is not acting on the center of the member. So that is eccentric. Due to this eccentricity in both the axes, movement will develop in both the axes of the member. So in the biaxial bending, the bending takes place on both the axes of the column. Columns are compression members. It is mainly designed to resist the compressive force. So here you can see the reinforcement arrangement in the column. So these are all the longitudinal reinforcement. The vertical bars are the longitudinal reinforcement to resist the compressive force. And these are all called the main bars. And these are all the ties that are called as the lateral ties. These ties are provided to hold the longitudinal bars in a position. Next, looks into types of the column. Based on the shape, the column can be square, circular, rectangular, and L-shaped column. So axial load with a uniaxial bending and a axial load with a biaxial bending, this I have explained to you before. The next, based on the slenderness ratio, we can classify the column as a short column and a long column. When the ratio of effective length to its least lateral dimension is less than or equal to 12, then the column is said to be short column. When the ratio of the effective length to its least lateral dimension is more than 12, then the column is said to be a long column. So when we design a long column, what we have to do is we need to consider some additional movement that is given in the SP16 code book. Okay, you can just see here the slender compression member that is given in SP16, the design need for the concrete member. So here the additional moments are given for the slender columns. You can see here when the compression members is slender with respect to the major axis, an additional moment max given by the following equation should be considered. So this has to be taken. So according to the axis of the column, major axis and minor axis of column, we need to consider this additional moment.